Okay, this video is just a little bit of an extra attempt to get you some help putting the ideas together. There are a bunch of things that we've done lately that kind of overlap and they kind of feel confusing once you mush them together, and so consider this would have been a warm-up on one of our days, on this day that we're going to do section 7.3. It's just a way for us to put together some of the chapter 6 stuff and the chapter 7 stuff all in one spot, and then we're going to toss in 7.3 after that, okay? So I'm going to call this kind of a review, just putting them together. You have a Quizzy Poo coming today, and so I need you to kind of understand how these work together. You might want to pause the screen so that you can read through the problems. Alright, let's take a look at the difference between these, okay? The first one says, we are flipping the coin 16 times, the probability of flipping exactly 5 heads. Remember that there's two things that you could get when you flip a coin, heads or tails. Those are successes and failures. That means this is binomial. Binomial means we are going to take in choose R, the probability of flipping a head, 50%. We want 5 of those. Probability of not flipping a head, 5.5. And we want 11 of those. So that's this situation. And I need to toss that in a calculator. Okay, 0.0667 basically. There's that probability. Alright, the next one takes that and says, let's do the probability of flipping more than 5 heads using normal distribution. Why did I say using normal? Because this is binomial. And so we're going to use our approximation method. Let me get your... That's this piece here. Where we are doing the approximating a binomial using normal. So we have to, first of all, decide on mu and sigma. So we have mu is NP. N is 16, and the probability is 0.5p. That's 8. And then we also need sigma. Sigma is the square root of NPQ. So it's N is 16 flips, P is 0.5, Q is 0.5. Let's see what that is. That is 2. Nice. Oh, true. Okay. The other thing that you wrote down on your formula sheet there was to do a continuity correction. I want to flip more than 5 heads, which means I don't want to include 5. I'm going to go 5.5. So to find my z-score, I'm going to have 5.5 minus mu over sigma, and that's my new z. That's 8 divided by 2 is negative 1.25. I'm going to grab my handy dandy table. Negative 1.25 is 0.1056. However, we are going more than, so we are going to the right. I need to do a 1 minus, don't I? So I'm going to go 1 minus 0.1056. I have 0.8944, so about an 89% chance. Ugh, there we go. Okay, so that's the difference between those two problems. I can do exactly 5 heads. I could do exactly whatever, unless I want to approximate it using a normal. Because flipping more than 5 heads, that would be kind of painful to do by hand, right? And so it's easier to use a normal approximation to help me get through that. Alright, I'm going to separate these. That's a lot of stuff mushing together here. Now we're going to look at the speed of cars passing through a checkpoint. The average speed is 61 miles per hour. There's mu. Standard error is 4. That's sigma. Okay, so what's happening here is, if this is normally distributed, we want the probability of a particular car passing through at a speed less than 68 miles per hour. So we need a z. 68 is the amount that I want to get, x minus mu over sigma. And we're going to go find our z just like normal, which is 1.75. Get your handy dandy table out. 1.75 is 0.9599. I wanted a speed less than 68, so that's it, because that was to the left. So 95, about 96% chance. Okay, don't round these off, leave it 9599. Find the probability that a sample of 30 cars passes through an average speed of at least 63 miles per hour. This is where we have to do the sample. And so we are changing to, this is chapter 7. Let me show you where this is at. When the sample is used, we are going to use these formulas. This is our CLT. Okay, so mu is still going to be 61, but sigma becomes 4 divided by square root of 30. There's mu and sigma. Alright, so to go find my z, I want at least 63 miles per hour. 63 minus mu over my new sigma. Okay, you have to change sigma every time you do a sample. So that word sample is what inspired this. Alright, and that gives me 2.74. I'll grab my table. 2.74 is at 0.9969. 9969. At least 63 miles per hour means I'm going to the right, so I need to take 1 minus that. 0.0031. There you go. Okay. I hope that helps to kind of put them all together in one spot. Since we're not in class putting them together in one spot all the time, then I just wanted to have a place to do that for you. Remember that to study for your quiz, there is a Quizlet out there for you, and then your quiz will be on the HAWX system. And I know that there are about 7 or 8 of you who have not yet signed up on the HAWX system and got that going. And so you need to do that. Go back and find the link. It's under updates, and you can go and look for it there, or I have it in one of the assignment posts too.